Name reaction part 2. In this part, let us see open or oxidation. So already we have seen that oxidation reaction, it is nothing but addition of oxygen or a removal of hydrogen. Here, the oxidation of secondary alcohol to ketone takes place in presence of aluminum tertiary butoxide. So alcohols and particularly secondary alcohols reacts in presence of acetone and aluminum tertiary butoxide to give ketone and isopropanol. So this acetone is converted into isopropanol and secondary alcohols are converted into ketone. Benzene or toluene is often added as co-solvent to raise the temperature of the reaction, or alternatively cyclohexanone in place of acetone we can use cyclohexanone instead of acetone. This reaction is the reverse of Mervin-Pandorf-Verlet reduction, or it is also known as MPV reduction. So this MPV reduction is a reverse of open or oxidation. Isopropanol in acetone in presence of aluminum tetrabutoxide. This isopropanol forms acetone and acetone forms isopropanol. Just here, the thing to be remembered, any ketone which is secondary, it is converted into any alcohol, secondary alcohol is converted into ketone. The mechanism of the open or oxidation involves the hydride ion shift mechanism. And in the step 1, secondary alcohol reacts with aluminum tertiary butoxide to form aluminum derivative of alcohol. This is the aluminum derivative of alcohol and tertiary butyl alcohol. So here secondary alcohol reacts with aluminum tertiary butoxide to form secondary alcohol derivative by aluminum. In step second, shift of hydride ion from aluminum derivative to secondary alcohol takes place via the six-membered cyclic transition state. So this aluminum derivative of secondary alcohol, and here the hydride ion transfer H minus is transferred from this to acetone, and this happens like this. This is the structure of this aluminum derivative. Here this aluminum derivative, this one is the structure. Aluminum derivative of secondary alcohol transfers this H minus to acetone, and this forms bond or coordinates with aluminum, and this gives rise to six-membered cyclic transition state. This six-membered cyclic transition state, through concerted mechanism, simultaneous bond formation and bond breaking takes place, which gives rise to ketone and the carbonyl compound, that is acetone, acts as a hydrogen acceptor within a cyclic complex. 1 mole of aluminum tertiary butoxide oxidizes 3 moles of alcohol, as there are 3 groups with aluminum. So open-or oxidation is selective. Other groups and carbon-carbon double bond are not attacked, or they remains intact. Synthetic application of open-or oxidation is this oxidation is specific for alcohols and is therefore suitable for compound containing olefinic double bonds or phenolic groups. These olefinic double bonds and phenolic groups remains intact. This open or oxidation only oxidizes secondary alcohol to ketone. This is the example secondary alcohol 6-methyl octat tri 357 enol. This secondary alcohol is only converted into ketone. This is the formed ketone in the product, and there is no any change in the reactant except this formation of ketone. Thank you.